Diels-Alder reaction is a very important reaction because it's used a lot in synthesis to make complicated molecules. On the left we have our diene, so we have two double bonds in that molecule. On the right is our dienophile, so let's take a look at that word. We know that phile means love, so the dienophile loves the diene. And the dienophile usually has at least one electron withdrawing group, which withdraws electron density from this double bond. So the dienophile is relatively electron poor. The diene, on the other hand, is relatively electron rich, so we have 4 pi electrons. So you can think about the electrons flowing from the diene to the dienophile. And this is what's called a pericyclic reaction. This is a one-step reaction that proceeds through a cyclic transition state. And if we think about electron density flowing from the diene to the dienophile, we could start with these pi electrons moving into here. So we form a bond between these two carbons. Next, these pi electrons would move into here to form a bond between these two carbons. And then finally, these pi electrons would move over to here. So think about all of those 6 pi electrons moving at the same time. And that would give us our product on the right over here, which is a cyclohexene ring. So if we follow our pi electrons, we'll start with these pi electrons in red. So these pi electrons formed this bond. Next, let's follow these pi electrons on the dienophile. So they start on the dienophile and they end up forming this bond between those two carbons. And then finally, the electrons in magenta right here on the diene move down to here to form the double bond and to give us our cyclohexene ring. But all of this happens at once. Now, I drew my electrons going around in a counterclockwise fashion. I showed my electrons going around in this direction. But it doesn't matter. You could have drawn your electrons going around in a clockwise fashion. What matters is thinking about moving your 6 pi electrons to give you your product on the right. Let's get some practice with some simple Diels-Alder reactions. And we won't worry about stereochemistry in this video. First, you need to recognize the diene and the dienophile. On the left is our diene, on the right is our dienophile. If we think about electron density flowing from the diene to the dienophile, I can move these electrons into here, so we form a bond between these two carbons, and these electrons will move into here to form a bond between these two carbons, and then these electrons down to give us our cyclohexene ring. So we could draw our product right away. We know we get a cyclohexene ring here, and then we would have our aldehyde coming off of that carbon. So following our electrons, I'll be consistent with the colors that we used before. So these pi electrons are red, and those electrons move over here to form this bond. Next, these pi electrons in blue moved into here to form this bond, and then finally the pi electrons in magenta moved into here to form this bond. So all 6 pi electrons move at the same time in this one-step reaction. Let's do the next problem. So down here on the left, this is our diene, and on the right is our dienophile. So this on the left, this is a diene, but notice that it has an interesting conformation. Up here, we had our diene in what's called the S-cis conformation. So S refers to this single or sigma bond here. But here we have the S-trans conformation. So we have our double bonds trans about this single bond. So we'd have to rotate about this single bond here to go from the S-trans conformation to the S-cis conformation. So you have to do that. So if you got this problem on a test, you could just do that in your head. And now you have your diene in the S-cis conformation. It needs to be in this conformation in order to undergo a Diels-Alder reaction. So now we're ready for our reaction. So we think about our 6 pi electrons. So we're going to move these electrons into here to form a bond between these two carbons. Notice this time we're dealing with a triple bond. Up here we only had a double bond, but alkynes can act as dienophiles too. So we're going to take these pi electrons and move them into here. So there's a bond that forms between these two carbons. And then finally move these electrons into here. So let's draw our product. So for this time, we have 2 double bonds in the ring like that. And then we would have this group coming off of this carbon, which is this one right here. So let's draw that in. So we have our ester, so we put that in. And then the same thing down here. So let's follow our electrons again. So we'll start with the electrons in red. So these electrons moved into here to form this bond. Next, let's look at these electrons right here on our alkyne. So these pi electrons move into here to form this bond. And then finally, our electrons in magenta move into here. So this is our product. All right, let's do another one. So let's go down here and let's look at this Diels-Alder reaction. So on the left we have our diene, on the right we have our dienophile, and we can start moving our electrons around because we already have an S-cis conformation. So if we move these electrons into here, then we form a bond right here, and then we move these pi electrons into here to form a bond here, and then move these electrons. So we can draw our product. So we would have this ring on the left, and then on the right we would have this. And we'll draw in this portion, draw in our carbonyls here, and this is our product. So following our electrons as usual, electrons in red moved into here. Our electrons, our pi electrons in blue moved into here, and our electrons in magenta moved over to here. So 6 pi electrons moving at the same time. What if you were given the product and asked to come up with the necessary diene and dienophile? So let's do a problem like that. So thinking backwards. So let's say you were given this on the right and asked what combination of diene and dienophile do you need? Well, think about moving those electrons in reverse. So let's look at our product here. Let's start with these electrons. I'll make them the same colors we've been using and move them in the reverse order this time. So these electrons would move over to here, and then these blue electrons in this bond would move over to here, and then finally these electrons in red would move over to here. So let's go ahead and draw our diene and our dienophile. So on the left, our diene, we would have our double bonds looking like that. And then on the right, for our dienophile, let me go ahead and draw our ring here and put in the carbonyls. So let's follow our electrons along here. So the electrons in magenta moved over to here. The electrons in blue were over to here, and our electrons in red moved over to here. So to check yourself on a problem like this, you could just take the diene and the dienophile that you drew and double check and make sure they give you the product on the right. So thinking about the Diels-Alder reaction in reverse gets you your starting materials.